Welcome back to the Advanced Microcontroller series. In this session, we will be learning about microcontroller interfaces with LEDs. And here is the agenda: introduction of LED, turn on LED using PICSimLab Simulator, toggle LED using PICSimLab Simulator. So what is LED? LED is nothing but light emitting diode. It emits the light. So this is the simplest device used in most on the embedded applications as feedback. It consists of two terminals, one the positive end is anode and one more end, that is the negative end, that is cathode. So this is the symbol of LED. So it looks like diode, but it having these two arrows. See here, the longer lead is anode and flat lead is cathode. So this is the LED. Next is the LED biasing circuit. So here we having two circuit. So which circuit works, this one or this one? So in the first circuit, the positive end of the LED is connected to the negative end of the battery, but in the negative end of the LED is connected to the positive end of the battery. But in the second circuit, see, the positive end of the LED is connected to the positive end of the battery and negative end of the LED is connected to the negative end of the battery. So here current is flowing in this direction. So this circuit is in forward bias condition and this circuit works and LED turns on. But here LED will not turn on. Here you can see same polarity connects to the same, but here same polarity connects to the different. So how to make this circuit, how to make this LED to turn on? What we need to do, turn on the LED. So here we having two solutions. Either you need to connect this battery in reverse condition like this. So then the circuit look like this, then LED turns on. Or so another solution, or you need to connect this LED in reverse condition. So how to connect in reverse condition? Let's see. So this is diode. Yeah. So now LED. So now we need to connect battery. So this is negative end. So this is the positive end of the battery. We need to connect. Now in this circuit here you can see negative end is connected to the negative end of the battery and positive end is connected to the positive end of the battery. So now what will happen in this circuit? The current flowing in this direction, isn't it? The current will flow in this direction. So now there may be a chance of short circuit due to high current. So what we need to do? We need to add load here. So I am adding one resistor here. So this is the resistor. So why resistor we need to add? Because it opposes the flow of current. So this circuit works. And here in this circuit LED turns on. This is about the LED biasing circuit. So which side will work in this diagram? Left side or right side? So to turn on LED we need to connect the positive end to VDD. we need to connect negative end. We need to connect the negative end to ground. This is the condition. So in this diagram, which is negative end and which is positive end? The longer lead is anode, isn't it? So here anode is connected to ground. So this side will not work. But here you can see the longer end is connected to VDD. When switch is closed, the current flows to VDD, isn't it? Current flows like this when switch is closed. So this circuit works and here LED turns on. Okay, here I am drawing one diagram. So see here, circuit. So here you can see this is diode. Yeah, now this is LED. So now I am connecting this LED to ground through resistor. So this is resistor. So here I am connecting this to ground. So this is ground. So now the negative end of the LED is connected to ground and positive end of the LED is connected to microcontroller pin. So this is the microcontroller. So positive end is connected to the microcontroller pin. Okay. So now current is flowing in which direction? So here current is flowing in this direction, isn't it? The current is flowing in this direction. So what is the source of current here? So this pin is RB0. Assume this pin is RB0. Okay. So now what is the source of current here? So before that, to turn on LED, we need to consider microcontroller pin as high, and to turn off LED we need to consider pin as low. So this is the condition for this circuit. Okay, so this type of connection, this way connection is called current sourcing circuit. Okay, let me consider one more example. So let me consider one more example. So here I am drawing one more diagram. So now here I am considering diode in reverse condition, not like previous. Okay, so now and this end is connected to the VDD. So in previous we connected to ground, now this end is connected to VDD. Now here this is cathode, not anode, right? So this cathode is connected to the microcontroller pin. So this is port B. Assume this is port B or port D. So now before that, sorry, this arrow is not proper. Okay, yeah, so I'm writing here. Yeah, now in this circuit, current is flowing which direction? This direction, isn't it? So here current is flowing. So the current is flowing in this direction. Here microcontroller is accepting the current. So this type of circuit is called current sinking circuit. So here to turn on LED, we need to consider LED pin as low, and to turn off LED we need to consider the microcontroller pin as high. So this is the condition for this type of circuit. So now we are using PICSimLab Simulator. So in the simulator we having LED arrays. So that is connected like this or in the previous circuit. Not like this, isn't it? That is current sourcing circuit, not current sinking circuit. So we no need to worry about this type of circuit. In this series we are going to use the current sourcing circuit. Now to turn on LED. So now we are going to write the code to turn on LED. So here we having main.c and main.h, two types of code. So here you can see hash include xc.h. Why this header file is used? In the previous session we discussed it, isn't it? So instead of finding address, so in the previous session we find the address of port B and we mention in the code, but instead of finding the address of port B tris B, we are using hash include xc.h. So this header file assign the address. So this is used to assign the address. So no need to assign the address again in the code. And here we having static void init config of. So inside this function we having initialization code, and inside this we having application code. So see here tris B equals to 0x00. So why it is 0x00? Okay, let's check in the data sheet. So to find the data sheet, either you search it in the Google Chrome, or go to the MPLAB X IDE. There data sheet option is there. Wait, I'll show. Yeah, here it is there. Click it. So it redirects to the Chrome. Okay, no need to search the data sheet again. Wait, yeah. So here you search PICSixteen-F877A. Yeah, this one. Choose. Then here click this. Then here you can see this one. Click download. So now here you need to search port B. Control F, then search port B, then keep search until you get this one. So here you can see setting a tris B bit will make the corresponding port P pin an input, and here clearing a tris B bit will make the corresponding pin an output. So now LED is input device or output device? We know, right? LED is output device. Okay, let's check in the PICSimLab Simulator. Click help, then click board. So here we having this diagram. So here you can see LED is connected to the microcontroller. No, right? This arrow is connected to the LED. So this is the output device. So see here, push button is connected to the microcontroller. So this is the input device. Okay. So now here you can see LED is output device. So we need to see this one. So clearing a TRISC-B bit will make the corresponding port B pin an input. So we need to write TRISC-B equals to 0 in the code, isn't it? So here I am writing TRISC-B equals to 0. Initially we considered LED is turn off. So port B equals to 0. So inside the void main function, so here we written init config. So it's calling this function here. Then while of 1. So this is the infinite loop which always run. So now we need to write port B equals to 1. Why? Because to turn on LED we need to consider the pin as high. So here port B equals to 1. So this is the code to turn on LED. But can we tell this code is written for LED or what? For other components, how can you tell? So in the schematic diagram here you can see port B connections, not only LED, right? So push button also there, keyboard also there. Then how to find this code is written for LED? So make it more readable. So here we writing hash define LED array. LED array is which one? Port B. And which is the data direction register? So here we having data direction register is TRISC-B. So LED array DDR is nothing but data direction register is TRISC-B. Yeah, now we need to use this one here. So where port B is there you need to write LED array, and where TRISC-B is there you need to write LED array DDR. So here you can see the same thing, LED array port B, LED array DDR TRISC-B, and here also you can see the same thing I written. So now we need to run this code in the MPLAB X IDE. So before that, how to create project? So go to the files, then here new project, Control Shift N, or here click to the new project, and here you can see under the categories we need to select microchip embedded. Under the projects we need to click standalone project, then click next. So here families mid-range 8-bit MCU and device is PICSimLab F877A. Select this, click next, and here we need to select the hardware tools, but this is optional, right? So I'm not going to select any tool here, just click next, and here you can see compiler. So if you install it successfully, the XE8 compiler, then here under the select compiler you will get this option, XE8 compiler. So click it, then next. Now we need to write the project name. So here I am going to write LEDs. So here verify whether it is created or not under the project folder LEDs. So it's not properly visible, right? So yeah, just you verify whether here created or not, then click to finish. Yeah, project is created now. So now what we need to do? We need to create the files .c file and .h file. So if you having any previous project, here right click to the project, then here you need to click close. No need to delete the project. So here we having so many files: header file, important file, linker file, source file, libraries and loadables. no need to worry about these files. So here we using header files and source files. All .c file comes under this and all .h files comes under this. So all libraries are comes under this and loadables are the executable files. So now right click to the source files, click new, and here you need to select main.c, and here you need to enter file name main and extension should be c, main.c. So now here you need to verify whether it is created or not, then click finish. That's it. Now file is created. Yeah, so here click projects and here you can see main.c is created or not. And next right click to the header file, click new, and here other. Then so here you need to select the C, not selecting, right? So you need to click the name or this icon. Yeah, it's selected. And here you need to select the header file, C header file. Then click next. Here you need to enter the file name. So here I am writing main. Then extension is H. So here you need to verify whether it is created or not. Then click finish. That's it. Now we need to write the code. So I am not going to write the code again. Just I am copying this. I will copy the main.c and main.h here. Okay. So now here I am having main.h. I am just copying this. Then I'll paste it here under the main.h file. And for main.c also I'll do the same thing. So here I am having main.c. Sorry, static void yeah, that's it, right? Here you need to save the file. If you edit the file, then again click to save. After that you need to click build. So here you can see build successful. So we need to upload this code in the PICSimLab Simulator. Before that I just debug this code. So here need to select the debug. Then here I am selecting simulator. Click OK. And here you can see, so build and load, build is successful. Then debugger console, and here you need to click the simulator. Yeah, resetting peripherals, resetting SFRs, resetting peripherals running, and here we having some warning, right? Watchdog timer has caused a reset. So how to disable this watchdog timer? Go to the production and here set configuration bits. So here we having option, right? Just click to this, then off. Yeah, now it is done. Before that, stop the debug, okay? So now again we need to do the same thing. No need to do, it's off. Again click debug, build is successful, debugger console is open to the simulator. So again same thing, right? So what to do? Go to the production set sim configuration bits, and here click to the generate source code. So here we have in one line, right, watchdog timer enable bit. Copy this line and paste it here after the header file. So this enables, but we want to disable it. So here off, watchdog timer enable bit. This is disable. Yeah, that's it. Now, oh, I forgot to stop the debug. Okay, you need to stop it first. Then you need to do this thing. Now save. Now no need to go to the production configuration bits then off. Just this line is enough to disable the watchdog timer. And click to the build. Now build is successful, right? Now click to debug, and here you can see where it is. Yeah, here you can see. Yeah, no warning. Okay, leave it. Again click build. Now go to the PICSimLab Simulator, and here we need to select the board. So PICGenios is there, right? Click this option, and here microcontroller. So PIC16F877A microcontroller we are using. So click to this option. So here clock we need to select clock 20. After that, here file, load hex file. But I forgot the path where I saved the code. So what I need to do? So go to the MPLAB X IDE, and here we having path. Home. Here we having the path. Just follow the path. So go to the not MPLAB, PICSimLab Simulator. Click file, load hex, and MPLAB project. So here LEDs. Next is default production LED.x production.x. Extension should be hex.x. Yeah, now. So now here you can see what happened to this LED. So here we need to select the port B, and we need to pull down the port D, because in code we written port B, and you need to pull this DIP switch to down. So now this LED is not turn on. Why? Click to reset. Yeah, now all LEDs turns on. So this is the code to turn on LED. Okay, now our next aim is to toggle the LED. So how to do this? So to toggle the LED, what we need to do? We need to use the complementary function, right? So here LED array equals to this one, complementary sign, then LED array, and we need to consider some delay, right? For delay equals to some value we need to consider. Then I am going to write like this: delay is greater than 0, then delay value is incrementing. So now, yeah, before that we need to define this variable unsigned int delay. So now, yeah, now no error, right? Yeah, no error. So can we write like this? But this type of delay is not preferable. Okay, so I'm just deleting this. Now previous line and this line both are same, right? Both will works as same. And this is the short time delay. So I am considering little, and int stores only 2 bytes. So here I am using data type long int. So now is this works? Okay, let's check. Here you need to click save and click build. See, build is successful. Go to the PICSimLab Simulator. Here no need to select a file load hex and all. Just click to the file, then reload last. Our aim is to toggle the LED. Yeah, it's toggling. But now here you can see, if I wanted to write like this. So here I need to switch on, or I need to on the buzzer. What will happen if this condition is false? Then this loop will not execute it. It will come out of the loop, isn't it? So this is what blocking delay. So instead of using blocking delay, we need to use the non-blocking delay. So how to use non-blocking delay? So now here I am using the if condition. So if delay minus is equals to 0, then this statement should execute. So now, flat bracket, yeah. So now we need to consider some delay here. So I am considering some delay. And here I am going to write delay equals to 0. Yeah. Okay, let's check whether it is works same or different. Go to the PICSimLab Simulator, click file, reload last. It works same, right? So both code works as same, but it having one problem, that is previous one is blocking statement, but this is non-blocking statement. So if you write switch code here, then if this condition is true or false also, if this condition is false, then this statement will execute it. So this is what toggle LED. Yeah, the same thing I written in the code. So now turn on LED one by one. So how to turn on LED? So in the LED array we having 8 LEDs, right? So we having 8 LEDs. RB7, then RB0, sorry, not RB0, RB6, then RB5, RB4, RB3, RB2, RB1, then RB0. Sorry, so here also RB1. So now how to turn on LED one by one? So initially all LEDs are off. Initially we need to consider all LED off. After that we need to turn on LED one by one. So how to turn on how to turn on LED one by one? So here I am considering RB0 on in the first line, and next I am considering RB01, then RB1 also equals to 1. So here 2 LEDs are turns on. So now after this, here we considering RB1 equals to 1, RB2 equals to 1, RB0 equals to 1. And next we considering RB3 equals to 1. And similarly next we considering so RB3 also 1, RB4 also 1. So similarly we considering here RB3 RB4 RB5, then RB5 also 1. Similarly we need to consider, so here we considering RB6 RB4, then RB3 also 1. In the last we considering all LED turns on. So like this we need to do. We need to turn on LED one by one. So for this what we need to do, how to write the code. So here we need to use the shift operation, right? Shift operator. So we need to shift one place. First we need to write this one high, then this one, then this one. Like that we need to shift, right? So initially I am considering one for loop. So for I equals to 0, it should consider this condition. Initially it is 0 and it should less than or equals to 7, and it's keep incrementing here. So what we need to do inside, what we need to write inside this, how to turn on LED. So we need to turn on LED one by one, isn't it? So how to turn on? We need to shift one place. So now here I am going to write when this condition is true, when this for loop condition is true, LED array equals to. So here I am going to write LED array is equals to LED array shift operator, then OR operator. Yeah, that's all. After that we need to consider some delay. So here I am considering for delay equals to means this is 5-second delay, then delay value is decrementing. Yeah, so this is the condition to turn on LED. So when this condition is false, all LED should be turned off. So after this one we need to write LED array is 0. Then we need to consider the delay again. So that's all about this logic. So here you can see the same thing. So we need to write one for loop. After that we need to write this line. Then we need to consider some delay. So if this condition is false, then it will come out of the loop, right? Then this statement will execute it. LED array equals to 0 means turn off. Okay, then again after some delay it will do the same thing. So while loop do? This is the infinite loop, right? While loop, it always runs. So okay, now we need to change. So what we need to do, we need to add character I. So after that, here we need to change. So here I am going to delete this. So after that we need to use the logic. So here now that's all. Save the code, then error is there, right? Unsigned long int delay equals to 0. Then char I. Then this one save for. Okay, let's build and check what is the error. Expected flower bracket. So while loop is open, for loop, and here for loop is closed. After that, this is while loop. Then we need to close main loop bracket, right? Yeah. Now save the code, then click build. Here you can see build is successful. Now build. Okay, build is successful. Go to the PICSimLab Simulator, reload last. Yeah, see, turn on LED one by one. So that's all about this session. In the next session, we are going to use the digital keypad. Okay, that's all about this session. Thank you all.